but this will be a good presentation and talk about solar and what the system. Yeah, like I said, Micah Johnson. Well, first of all, Micah Johnson. Okay, cool. Yeah, my name's Micah Johnson. Company is Solar. This is about our company. This is about me. I just know our person from the top. Our website. So we saw that'll be important in just a second. We believe in alternative energy like solar and chemistry. We're a Rochester-based company. We're here in town. I think we just hired versus up to 13 people. So for us, that's huge. And it was just the two of us for many years. And Kurt is a NAPSEP certified PV installer. I'll tell you about that in a minute. Most of the pictures in here, of course, are systems, not because I'm trying to highlight our systems, just because I can use that copyright free. And so that's when I use any other pictures, I try to do it as much as I can. And more just after my name, there was the title ICLS. That's my unofficial job with Solar Connection in charge of lots of stuff. My official job is operations manager. If this presentation doesn't go well, that will be former operations manager. North American Market Certified Energy Practitioner. This is the highest certification you can get in solar. Just the reason I mentioned Chris, he's local chemistry, he's no slouch. He took classes for years for this certification for this test. He studied for months. When he got out of there, he said he was sweating. It is hard. It's a really serious certification. There's only about 2,000 people in the entire United States that have it. And it's been around for well over a decade. So it's a serious certification. Not recognized for the state, but it's just fun. Just real quick on the schedule. When I was talking about what you thought might be interesting, because I give lots of classes and presentations. My longest class is about 4 hours long. We're not going to spend that much time here. You hope. But I was talking to Dean about what do you think might be interesting? I had all these topics that I presented. So what about this? What about this? What about this? And every single one he said yes to. So we're going to start with solar. Actually, we're going to start with the beyond and get into some of these other things. And it's PV focused photovoltaics for a little bit of solar. We also do solar thermal systems a little bit. They're generally not as popular and only work in certain areas. We can get into that in the questions if you want before we know the keep this electrically focused, which I find everybody like. We have here in the area. How many people would argue electric co-op? Anything itself, people? Try to what's in there? All right, pretty much that's three. So we did for this co-op back in 2011 was a small demo system. Revenue for you, the small system that whole use for the power company. And a step down system we did on a hillside over in Missouri. It's important. I think things are put up with some aesthetics in mind. Solar panels on a 25-year warranty on them. long, long time. So it's really important that it looks good. That's my bias. A little bit about resources here. On the right side, you've got total recoverable resources. Going up the right side, your total recoverable resources on the planet of those types of energy sources, and yearly potential and everything else. The solar bubble would be so big. It seems like it's awfully big. The thing to keep in mind on this is assuming this is only what falls on land, and it's assuming 65% of the energy is lost in the atmosphere. And I try to always put my sources up in this if you want me to talk about it later. A lot of people ask me if solar work in Minnesota. Well, we're not the Southwest. Obviously, the Southwest is the desert Southwest. However, compare the color we've got in Minnesota to Germany. Now, why do I put Germany down there? Germany is the north side of the world. They get 50% of their electric demand with solar alone on a good day. They have somewhere around 4,000% more solar in the entire United States. Somewhere around. Already asking about the snow, of course, the snow problem. Yeah, on a typical house setup, they'll have some snow cover in the house for a couple days here and there. It's pretty fast. It comes from the snow fast. This is worst system I saw by. I think this was like 1 o'clock, Thursday after a snowfall. And the city panels, of course, are melted off already. The systems have. He says he loses about 2 or 3 weeks a year. Not a big deal. I'm not going to worry about it. You have a couple of crazy people that are, getting a plastic coated roof. I can scrape it. That nature of this course. That's just my take. We're pretty accurate with our production estimates. We can accurately predict when a given roof is in a certain direction and how much we can predict what a system will produce. I can predict what it'll produce in a year very, very confidently. Something only varies by about 4% a year. The hot water system. Now, the reason I bring this, I want to talk about this. You can see in overcast. This was in December. This was the winter report. This was December 2011. Where these solar collectors out. They had been sitting in the detached, unheated garage all night. The day before we put out the racking system, so we get December day. It was probably, I don't know, 17 degrees out or something like that. Overcast. We get the panels out. Bolting down. We didn't have the piping on there yet. And so this is a little open. So all there is this area. Now it's good. Just make sure it's not water. But at the time, what was this area? So December day, overcast. I take my glove off and put my hand up to see how hot the air is. It was so hot. I'll just hold it up, kind of pull it away this back. And you can see how it is actually so really isn't affecting us too much. Then coming out of the behind, these are roll-up solar cells. These big rolls, and then just roll them out and tack them down. That's when the sound goes on. And then for some way, do it. And for your EV, they've got a big antenna in Austin, Minnesota, a couple of them. We're a bit talking about it in Rochester, but Austin is not. Oh, and the decathlon is a all these houses that are residential zero. Solar cells built in. Not the entire side of the house on the outside. We get the collections, but that's something totally different. All the cardboard to show me this more and more. I've gotten a couple of requests for these and design a few. So far, nobody's bid on them, but see what happens. Other vehicles, and wouldn't want to ride one of these, but I wouldn't. Not very far. But you gotta walk before you can run, right? I don't want to ride a Model T. Rochester Cemetery, we helped them get a hold to the solar gold up in Minneapolis area. They had to add this PVC pipe. This is an for the local company. They had this PVC pipe. That was really fun. Again, I wouldn't want to fly one of these, but that's one of the gotta walk the plate one. International has 14 megawatts solar. This actually only has 8 megawatts of solar. 14 megawatts. So far back. OBS is investing in solar huge. Investing in solar huge. Solar is now something like a $20 billion worldwide industry. Apple is investing in solar that they are now 100% solar power. Very close to it. There's any justice in this world as soon as we're done in solar power. God will introduce a newer, smaller sun that is compatible with that. Building integrated EVs is something that's all these windows up here, and except for all those windows have solar cells in them that let some of the light through, but not all of the light through. And then on the lower right is solar shingles. And down a certain T have solar shingles available for just release them in the solar. That they have water intrusion issues. And I think we're very lucky in some of the water that comes out of it. Solar cells, this is the laboratory level. I don't think we're going to completely transparent. And there's a couple of ways of doing it. Either there's absorbs the wavelengths of light, or you have ways of going off to the sun for the solar cells. And laboratory level, this is a better handle. So, community solar is something that's hitting Minnesota really big. We're on 600 megawatts of community solar online in the next couple of years. And this is the very first community solar installation in Minnesota, right here. This up in Rochester area. And this is a system where there's one central plant and so we can subscribe to have equivalent amount of energy for one or two solar panels credit on that. It's kind of an interesting way for people in apartments and condos and so on to invest in solar. I always get the question solar and all the mid-sized systems solar is cheaper. When you start factoring in land costs on megawatts, now wind is cheaper because a megawatt of solar is like 4 acres, and a megawatt of wind is for a tower. So once you factor in land costs on large systems, wind is actually the cheapest form of energy if you're buying the wholesale market. But that has to do with anything this size, 100 kilowatts or less, solar is going to be cheaper. If the wind comes down, price will make anyone for right now. Portfolio doesn't have any moving parts that you schedule for. And it's providing power during the day, which is what we believe is more power. All the places. It's a system in this known as a pilot series of a bunch of and people are asking about tractor systems. Yes, some tractor systems. It concluded the winter of 2014 with all of us really good at it. A couple of lines on what my software predicted the system to do. Lines what it actually did. You can see the snow losses in December. That your period they were running about 11% of what my software said would do. So most of my systems aren't running quite that far, but most of them are running about 5-6%. Real quick on the policy. Like I said, I'm hoping we'll have a little something for everyone. And going through some of the topics. I don't know how remote industrial applications, ocean-based, actually in the space for this looking like satellites. Really quickly. Mike and I, of course, I have a little something about the environmental aspect. We all know, of course, this is one of both sides, and I just want to use that as a base with both when it comes up, of course, references and so on. But I'm going to talk about something that people talk about water use. The water use of different technologies and producing energy. Well, little things that and how we're talking about this. It starts here is all of this water, all of this water, and all the oceans, all the ice caps, everything. Fresh water down here. We have, water, fresh water. About 2/3 of that is in the glaciers and ice caps. If it's starting to get in the national conversation, there's National Geographic, the magazine. And just came out with a study just not too long ago on water use and what's going to happen in the future. This is in fact, of course, just water. And a natural gas. But the water use rate is alarming. Or you can just in water, we have a kind of theory on one thing put out. And we know what's much more, right? On the left hand is the top 10 renewable states and how fast their electric bills are going. The national average. And the bottom 10 renewable states and how fast their electric bills are going. Locally as well, this happens to be wind, but it's Wisconsin having the least amount of renewables has the highest electric bills. Minnesota's in the middle. Iowa having the most amount of renewables has the lowest electric bills. And give a presentation in an election year, we're going to talk about jobs. And it says $20 billion a year. We don't have any fossil fuels in this. I'm going to be just a small percentage of the connection comes in Rochester. This is just for $1 million here. Jobs for the one. Some people think solar panels are ugly. Can't read that this is solar on the left, the full mountain top. The system we did here in town with solar up on the roof and we built it over the deck. On the underside, it looks like this glass on the front and back cells. Like through that you can read to it, will shade it on the back. Policy is a little bit. Hopefully, you can read that. Solar is the #1 source of energy. #1 most source of energy across all. Let people get like solar and then number of people that do it on the national level. Open up energy markets to make it a framework of different sources. All that's great stuff. Why is it still
install, but it's a lot easier to drag around town. This is a demo panel that we have. It's an actual solar cell. Leads on the back. Solar panel here.
So on the hail question,
I can kick them with my steel toe boots. It's glass, tempered glass. Yeah. I have a video of them driving a pickup truck over them. If you ever want to search it, I didn't want to make it too weird technically here, but if you ever want to search it, it's on YouTube. Just do Solar World Quality. Solar World is just the manufacturer. This happens to be their, have manufacturing both in Oregon and Germany. And Solar World Quality, if you want to, or email me and I'll send it to you. Literally have a video of them driving a pickup truck over it.
Slides back to get that photo.
Yeah.
What percentage of that homes is provided by the solar?
Yeah, you were looking at this one with the on top and the pergola. This is more than 100% of their electricity. If I put solar in my home, well, let me back up. I've got a 2,000 square foot Rambler in Rochester here. I'm reasonably efficient. I'm not crazy. I don't live in a cave or anything. I have an old air conditioner I still need to replace. I've got an old washer and dryer I still need to replace. Okay, so I'm reasonably efficient, but I could be better. This would provide 3 times as much electricity as what I use. Now they've got some young kids running around and so on, so. Location, we'll get into just a couple of thoughts, obviously. This is from Bing Maps, so this would be the south view. I also threw in the east view so you can kind of see the height of the trees and some of the shadow. This is probably not going to be a great spot with a big tree in the front. This is a better spot, obviously. So we really want to have a spot that's sunny, you know, kind of 9 to 3 is our prime time. And if you're putting a whole bunch of planting a forest in the south yard, probably not going to be the best place in another 10, 20, 30 years. Is there space up there? Something like this. Really hard to get large rectangular panels on this roof on the left. About 65 to 70 square feet per kilowatt of solar, roughly. That's a moving target, but right now that's about accurate. Per kilowatt of solar, not kilowatt hour, kilowatt. They're rated by kilowatts. Each panel is, you know, say, well, there's a whole bunch of different sizes, but say each panel, let's just, for example, each panel here would be 250 watts, 4 of them make a kilowatt. And that's the rating of the panel, rating of the system. Now, how does that convert to kilowatt hours? Let's just take this example here. I got a 5 kilowatt system here. On this spot, it's producing about 6,000 kilowatt hours per year. If I put it in the garage, it's still a 5 kilowatt rated system. Well, you guys know how this works, but it'll produce no kilowatt hours. So the location, the tilt, the angle will affect that relationship. Can go on flat roofs. This is IKEA in Bloomington. For a short time had the largest installation in Minnesota, but now there's been several more that have beat that. Ground mounts, and my favorite use of a ground mount. Fanciest canoe storage facility in the county. Ground mounts typically cost a little more, of course, because when I'm on a roof, I'm just bolting it to a structure. When I'm on the ground, I've got to build the structure first. Concrete footings down 4, 4.5, 5 feet, whatever the structural engineer that designs it. We've got steel, galvanized steel, and aluminum structure. Can work facing east-west. Obviously, south is the best, but we do have several systems that are east-west facing. Obviously, you can see it here, and then this is, he did it on both east and west of his machine shed here. It's about 18 to 20%. The program will tell you it's about an 18% drop in efficiency. I'm going to tell you it's probably closer to 20% just because you're going to have a little more snow losses. So this system is that east-facing system. And you can see some serious snow losses because it's only getting sun in the coldest part of the day when it's east facing. Say that again? Dirt. The question was, how about dirt? Yeah, it can get, they can get a little dirty at times if it doesn't rain. They're self-cleaning in the rain. I do tell people that have them out in farms and so on, that if it's combine season where there's a lot of dust, or we got, you know, wildfires in Canada or something, you might take a hose to them, you know, or just wait for it to rain. If it rains regularly, let nature take its course. But they can drop 5–6% if they get really dirty. Yeah. You have a question up here? No? Yeah. Really loud. Do we have a right to the sunlight? Oh, good question. So that varies by location. The rules on that vary by location. Most counties and municipals and so on now have zoning regulations when it comes to solar. And, you know, there's as many rules out there as there are municipalities and counties and authorities having jurisdiction. So yes, some places they say, hey, if you put up solar panels, your neighbors can't build a great big tall building that will shade them. Some places say that. I think Rochester zoning ordinance says that. But again, it depends on where you're at. Yeah. Yeah, I'll get into that. Yeah. I'll wait till I get to those slides to answer that question because I've got a whole series of them on that. And selecting equipment. You got another one? Yeah, good. Yeah, yeah. Well, for sizing, what I'm looking at when I go out to a place to size a system, first thing I'm going to look at is their yearly electric use. Again, I always go by the year because, you know, sunny days, cloudy days, it can vary, but yearly I'm very accurate. So first I'm looking at the electric use. Next I'm going to go up and measure out the roof, how much space is up there, how many panels can I fit, and what direction they're facing. I'm going to do a shade analysis. I've got a couple of shade tools that can, I think I got some pictures of them later, that tell me exactly how much sun access there is in that location, or, you know, are there neighboring trees or what have you that can bring it down. And then I'll run it through the software and I can predict exactly what it's going to produce, you know, within a few percent on a yearly average. So those are the things that I'm going to look at, and I've had systems around. We've been in business since 2010 and we track all our systems, so I'm very, very confident in the software. Yeah. I'd have to do the shade analysis on site. Yeah. I mean, unless you tell me it's completely shade free, then I'll get out my, yeah. Then I would go, the PV watts program, you can run it yourself if you want, or we could run it, but you know, roughly per kilowatt on a good site, I'm going to produce about 1,200 kilowatt hours a year. Ground system a little more because I'm tilting it up. So roughly you can kind of use that 1,200 or 1,250 average. So if I take my yearly electric kilowatt hours, say I'm using, you know, 8,000 kilowatt hours a year, divide by 1,250, that's how many kilowatts of solar I'll need. Again, assuming a good site from a sun. You know, if there's a bunch of trees, well then that ratio is completely different. Yeah. Yeah. We're only adding about 2.8, 2.9 pounds per square foot. So most of the time, no. When I get in some of these old egg sheds, then once in a while we'll beef up the system, add some trusses or something. If their trusses are 16 feet on center, we're gonna beef that up. But generally, we've had to do a couple of structural analyses for installations, and every single time it's happened, they come back and say, no, you're fine. We'll do both. We can do both. I'll get into the differences here. There are 4 companies that make panels in Minnesota. Most of the time, it's not cost effective to do them because if you're on the Excel grid, one person, 1 or 2 people work, there's a made in Minnesota rebate for Excel Energy people. Well, they have a rebate, so they bring the price up a little bit. Plus, they're small operations. So there are companies that do that. I'm an approved installer with all 4 of them. I wouldn't recommend them unless you're getting that made in Minnesota rebate, because I can get you high quality American made panels for less. Correct. Installation. Yeah, my job can't be outsourced. I'm an installer, by the way. I don't know if I mentioned that. My first job now, of course, operations manager. I'm doing a little bit of everything, but when I started, I'm an installer with solar connection. I still enjoy installing. I like being up on the roof, putting these things up. And obviously, as we've grown, I've taken on other things, but I don't make my living on commission. Both. Sometimes, yes, net metering. I would say the majority of systems are net metered. That's the most common way because batteries are expensive. But yeah, we do battery systems too. Yeah, good question. So let me pull up this picture here. So the question was, what do you do when you have to change your shingles? So there's been the old school way of doing things, of course, hire someone like us, tear all the panels off, re-shingle the roof, we put all the panels back up. We're not reinstalling the entire thing, so there's some savings, but it's kind of an expensive way to do things. Now, the issue that I started, as I started looking into this and researching this a little bit, the issue that I came up against every single time is the shingles underneath the panels don't age. They're not getting hit by any weather, no UV. It's the most expensive roof preservation system you'll ever have. So the shingles underneath the panels don't age at all, but of course you have all these areas where there's vents, or you got to have some walkways and required by code and so on around the edges. So those shingles are going to age at regular rates. So what can we do about that? I went around to some of the roofers. We're a member of Rochester Area Builders, so I went around to a bunch of the roofers in Rochester Area Builders, had 4 conversations with different builders, all separate conversations. And the question was, can you safely and waterproofly, if that's a word, shingle around the panels and get all these shingles around outside of them and keep it all safe and watertight and so on. 4 conversations, I got 3 different answers. One guy was like, oh yeah, no problem, I can do that in my sleep. So I threw that one out. One guy looked at some pictures and said, no, I don't think I'd do that. I'm not comfortable with that. Okay, fair enough. 2 other roofers, one was Brower Roofing. I only remember that because he did my house, did a bang-up job. I forget who the other one was. They both had the same answer, separate conversations. They looked at pictures, they asked questions, how far up off the deck, because the solar panels are up off the deck of the roof, because keep them a little cooler. And they asked some questions about it, and they both said, yeah, I think we can do that. And their biggest concern was the color of the new shingles isn't going to match the color of the old shingles. And I said, the old shingles are underneath solar panels. You're not going to see them anyway. So so that's what I know. You know what I know now. Those are the 4 conversations I had.
So you talked about better efficiency, if there's filters on the ground, you got filters around the manufacturer. Anyone when he left you build a solar structure underneath it, you would
You can. It's called sawtooth installation. I don't have pictures of it because I haven't actually done one. I've designed them, but they've never gone forward. If you ever want to search solar sawtooth, you'll probably see it. I think you got to consider the aesthetics though on something like that. They look funny. I've seen them. They look kind of goofy, and I'll talk a little bit about tilt-up systems coming up. The panel warranty allows for 0.5% per year in degradation of the panel efficiency. So having said that, since 2010, I haven't seen any degradation yet. It will happen. I mean, it's going to happen. But the warranty allows for 0.5% per year. For example, from Solar World, I think there's some other warranties are 0.7% per year. I've seen some of those. Some of the Chinese modules have that. Say that again. Okay, the question was, what is the end-of-life failure mode? Generally speaking, it's going to be in the wiring. It's probably going to be in the wiring. I mean, there are panels that are 50 years old still producing power today. I mean, the wiring is eventually going to, the insulation is eventually going to, being outside and freezing and thawing cycles is probably what's going to fail. Yeah, good question. I was asking about the lifespan of the inverter. Yeah, so I mentioned the failure point of the panels is probably the wiring. There is an inverter. We'll get into parts in a little bit, but yeah, inverters typically have a 10-year warranty. They'll push that out to 25 years for microinverters. You don't want microinverters. I'll tell you why, at least not around here. So yes, generally speaking, the rule of thumb is that you replace the inverter once over the life of the system, maybe twice if you really get, if you get 50 years out of it, you might be replacing it a couple times. So inverter costs right now are, well, it depends on the size of the inverter, how many, I've done systems that have 10 inverters. So, but replacing one, maybe $2,000 or $3,000 in 15 years when it actually goes out. What are they going to be? Are they going to go the direction of DVD players, high def TVs, or are they going to stay high? I don't know. I don't have a crystal ball. Good questions. So let's get into the parts. Obviously, the solar panels produce DC current. When I'm teaching my community ed class, I like to stump people by, I give them the trick question, what has higher line, what has higher line losses, DC or AC? You guys know the answer to that. They're both the same, at the same voltage. You've got to have conduit feeding power to the inverter in the basement or garage or what have you. This is just kind of the traditional system. I'll get into variations on this. If you ever get involved in this stuff, if you ever put one of these in, or if you know someone that does, if you're working on it yourself, get your code book out. DC is interesting. Yes, you got to have metal conduit. Please do not do something like this. This was not something we installed. Please do not. Yeah, terminal blocks, folks, not wire nuts on DC with varying voltages, which means varying current out in hot environments. Not a good mix. A couple of different pictures of these are traditional inverters. I'll get into other kinds, but these are just different manufacturers. Interconnection point, it can go right into the breaker panel. The inverters, it's a straight 240 volt. Nominal, of course. It's going to match the grid. It's what it's going to do, depending on how far you are from the transformer and the lines and so on. It's going to match the grid, but it's cleaner power than a generator. Yes, it's pure sine wave, so if anybody had that question. Very, very clean. Cleaner power than a generator. 90... I've put in, gosh, at least half a dozen. Probably closer to 8 now that I think about it. Different companies, yeah. I'm a believer that there isn't, as far as manufacturing, yeah. A couple of them manufacture here in the States. There's a couple that manufacture in Europe, and there's a few that manufacture in Southeast Asia, China, Taiwan. Yeah. I'm a believer in not one size doesn't fit all, so there's different technologies for different purposes. I'll get into a couple of those. Can just feed right into the breaker panel. With a back fed breaker, you've got to watch your bus bar rules. You can only go the sum of your generation sources, meaning the grid breaker, your main breaker, plus whatever the back-fed solar breaker is, has to be less than 120% of the bus bar rating. Now, there's nothing that says you can't put in a bigger bus bar and keep your main breaker size the same. So you can really get kind of creative with different ways of hooking these up. Can go right into the meter. We have some dual rated lugs on the meter sockets. This is from a spec sheet from Millbank, I believe. If we're going to do CT metering, it's probably going to be H-taps. It's usually a farm system. We're just going to use H-taps. We can go into tap boxes. This is a solar interconnection. 3 of those lines obviously are ours. The rest of them already existed on site. Can get into switch gear. Yeah. Correct. These are all different ways of interconnecting with the site electrical or the grid electrical setup, whatever the case may be. Yeah. So different ways of doing it. Just depends on what's out there and what kind of ampacity we're dealing with. This was probably 200 amps coming into this guy. Well, I'm not going to usually put that. I've done it a couple times where I've gotten a 400 amp breaker panel. There's a couple of times where that's been necessary, but a 400 amp breaker panel is a special order. You guys probably know about $800 or $1,000. When they've already got an existing tap box that can handle that, we'll usually go that way. We can get kind of complex. All of this was entirely for the solar. Yes, compensating. I'll get into those. Yep. So that's kind of your rule of thumb system. Your rule of thumb system does not have batteries. Yes, you can do batteries. We're one of the few contractors that actually works with batteries. I think the only one in southeast Minnesota that I know of. So most systems are tied to the grid, just kind of your rule of thumb system anyway. That means you're kind of using the grid as a battery. That's roughly how it works. Net metering is the name of the program. The solar production does go down when the grid goes down. Obviously, the solar system knows that when the grid goes down, somebody's up on the lines, fixing the lines. System knows it's not safe to put up power, so it shuts down when the grid goes down. That's the downside of not having batteries. Battery system, of course, will keep on going. System will shut down within a second of the grid. As soon as it senses the grid, or once it gets out of, I think the voltage range that it can handle is, I believe, within about 7% of 240. Once it's outside of 7% of 240 voltage coming from the grid, it shuts down. And it stays down for, even if the grid comes right back up right away, inverter doesn't put power back out for 5 minutes. Required by, U.S. National Electric Code that it stays off for 5 minutes before it starts. So it's got to sense a stable grid for 5 minutes before it comes back on. So that's one of the downsides. I'm a believer, and I think the 2020 electric code will solve this issue. It's too late for the 2017 code, but I think the 2020 code will do this. There's no reason that you shouldn't be able to use the power during the day, use a transfer switch just like a generator. And you should be able to use your own solar power during the day. At least charge your laptop or cell phone or something. I got to believe that we will be getting to that point. Unfortunately, the code is still, you guys know the code. It's slow to change, and they're, this newfangled solar thing is a little weird. Year-round maximum tilt for our latitude is 38 degrees. You will see sources, including solar textbooks, that will tell you it's the same as the latitude, which is 44 degrees here in Rochester. Not true. We can nerd out about why that is later, but trust me, I've calculated it dozens of times. It's 38 degrees. This is from Chicago. This is the closest I could find that shows you on the horizontal axis the azimuth, meaning how far off the south, 0 being south in this case. I wish they used 180. It would make a little more sense, but whatever. And tilt angle. And you can see there's a pretty big range of tilts where you're going to be in the top 5%, and a pretty big range of, how far off the south you are. We're going to be in the top 5%. Now, shade, of course, being the other issue. Somebody asked about tilt-up systems. This, you can see this. This is from the south side of Silver Lake. You can look across to the north side and see this system. They have, I think, a 212 pitch roof, and when you're getting down to 212, you know, then you probably want to be doing something, because at 212 you're just not going to shed the snow fast enough. 412 pitch roofs, they slide off and you lose a couple weeks here and there. At 212 you probably lose most of the winter just because it's just not going to slide off very quickly. So they did a tilt-up system. Everything's fine on it, except when you consider what it looks like from the other side. And they knew that. They knew that going into it. That's what they wanted. They asked us to put up this system. We raised that objection with them. They said, no, this is what we want. This is the area we want it. We know it's going to look like this. Okay, fine. Most of the time, I'm going to avoid this. I'm going to caution them. And that's what we did. We cautioned them and we showed them pictures and we said, this, every time you drive up to your house, this is what you're going to see. They said, nope, that's what we want. We're okay with it. All right. Sure, yeah. I mean, we've designed, I had another tilt-up system over by just south of Assisi Heights, and we designed basically we just took a bunch of metal roofing, and we were going to attach metal roofing to the posts and so on to make it look a little nicer. In his case, there was nothing behind him. They back up to Assisi Heights. There's no aesthetic reasons. He was worried about snow collecting underneath from blowing snow from the north side, which hasn't been an issue, but we designed that and they ended up not doing it. They ended up not getting the metal roofing around it, but certainly could be done. Or, no reason you couldn't put a big, Go Vikings banner or Go Packers banner, whatever, Yeah. 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 Question is, with this thing, we're dealing with some high winds that are going to some good wind loading on this. Very good question. Everything we do, we're a full licensed contractor. Everything we do has to be built to Minnesota Building Code, which is 90-mile-per-hour wind loading. I get the specs. I turn in the specs for our areas, all the exposure categories and everything to the manufacturer, this racking company. Their engineers look at it, come back with a stamped statement saying, nope, you're good till 90 miles an hour. Batteries we'll talk about a little bit, and there are monitoring systems. These are just getting into different options, different things. We'll talk about microinverters and DC optimizers, what are those, and helping with shade and so on. I'm not going to get into solar air heating or solar hot water. I already mentioned that, but they are out there. Ground mount systems we talked about a little bit. Trackers are something that are big. The trackers are the systems where you can have a single axis tracker where you have a single axis, and it just goes back and forth like this throughout the day. Or a dual axis tracker, which we're more used to seeing, where it follows the sun, right? It can tilt this way and this way, dual axis. They were really big, 10, 15 years ago, they were more common. Back then, the price of the cells was the super most expensive part, so it made sense to maximize the sun access to each cell or each panel. Now the price of the panels has fallen enough where it's actually now cheaper to just put in more panels than it is to put in a tracker. So now you don't see them going up hardly at all anymore unless it's really a space limited issue. And that's just the installed cost. That's not counting maintenance. Anytime you add movement, you add maintenance. One of the best things about solar is there's no moving parts. Off-grid. When you're talking, off-grid or battery backup. You can have battery backup where you have power when the grid goes down. You have some batteries that just kind of sit there, and when the grid goes down, the batteries take over. Or you can have completely off-grid, but these two houses are both completely off-grid. Backup systems, when you're doing just a backup where it's just going to take over when the grid goes down, I got to be honest with you, generators are cheaper. It's cheaper to just have a backup generator than it is to put in batteries, because batteries are still expensive. They're coming down, they're not there yet. living completely off-grid, that's a whole different conversation. Off-grid is a lifestyle. So these folks built this wonderful home in the lower left here for people listening online, built this nice home over by Whitewater State Park. And two things to consider. First of all, it's a 1,300 square foot home, very modest, tiny fridge. They have a washing machine, but no dryer. They're just LED everything, super, super efficient. 2-foot thick walls, R40 in the walls, R60 in the ceiling. They brought in these windows from Canada. I mean, this is a super efficient house. My cost on their batteries was about $6,000, not including installation. Just to get them delivered there was about $6,000. So you're you know, and that's a small, super efficient home. And they talk about waffle days. This is what I mean. Batteries are, off-grid is a lifestyle. They talk about waffle days. If they wake up in the morning, first thing they do is they check the voltage on their batteries. They check the health of the batteries. First thing they do every morning. And if the previous day was sunny, battery's in good shape, they can fire up the waffle iron. If the previous day was cloudy, they don't have waffle days. Most people don't want to live that kind of lifestyle. And I would say even more than the cost of batteries, that I would say even more than the extra cost, that is the reason why I don't do as many off-grid systems. Most people just don't want to live that kind of lifestyle. And that's the lifestyle that you have. They have, neither of these homes have any connection to the grid. No, this one couldn't on the lower left. For them to hook up to the grid was about $12,000. So for them, it was kind of financial. I mean, they wanted to be off grid anyway, but it was correct. But I do have off-grid homes in places where it's a retrofit, like it's a house on the grid, and they say, no, we want to stay here, but we want to go off-grid, and they disconnect from the grid, and we put in a bunch of batteries. So the Tesla Powerwall is supposed to change everything, right? Not really. Sorry, I haven't updated this. They've discontinued the 10 kilowatt and the 7. They said, oh, okay, yeah, it's actually only 6.4. But Tesla Powerwall isn't really, well, there's a couple issues. First of all, I can design a system that gives you 6.4 kilowatt hours for about 2/3 of the cost. Won't come in the nice pretty box that you can hang on your wall, but won't say Tesla on it. But it's certainly not that cost effective, I don't believe, at least so far. The other issue is this little guy right over here. You're not allowed to put in a 350 volt device in a residence. There's a reason that Tesla announced these for sale back in June, and they still haven't installed any in houses. They've installed them in commercial applications. They've installed them in houses in Europe and in Australia. I haven't heard of any houses getting them here in the States yet. So you can install it outside, except for not in Minnesota, if you look at the operating temperature. So they've still got some re-engineering to do, I think. Actually, to be honest with you, I'm following the market a little bit. I think UET is going to put Tesla out of business. They're coming up with the flow battery. You guys probably know more about this than I do. The flow battery, I think, has the potential, from what I've read, has the potential to beat lithium as a technology once they scale it up. So it's going to take a little while. You guys know that. Incentives. The federal tax credit did get extended. It was set to expire this year. Now it got extended out to 2019, and then it has 2 years of a step down. Businesses can do accelerated depreciation. That's why you see a lot of farms up there. Farms can, you know, depreciate it as a business asset. Just like anything else, you buy a truck, you depreciate it. You buy a new tractor, you depreciate it. Just standard business depreciation. Minnesota throws in no sales tax, and it won't increase your property taxes. Of course, the net metering. Utility company rebates vary widely, and the co-ops now have extra fees on solar. They actually charge you more to have solar, like People's Electric Co-op and Steel Waseca and so on. Tri-County is not doing that. RPU is allowed to put on extra fees, and they looked at that and they said, no, that's stupid, we're not doing that. Now, whenever we're talking about subsidies, let me preface this. I'm a political moderate. I'm not a huge fan of subsidies myself. I'd rather see them all go away and you know, let the market decide. That's more my take on things. However, if you look at this, average annual subsidies, this is the average in 2010 dollars. How much oil and gas gets, how much nuclear gets, biofuels and renewables. People say to, every once in a while people say, oh, solar wouldn't even work without the subsidies. I'll be honest with you folks, oil and gas wouldn't work without the subsidies. You take away all of those and I'll be the cheapest thing up there, guaranteed. Even with the batteries. Amount you've paid towards fossil fuel subsidies as a taxpayer over 5 years. Amount you've paid towards solar over 5 years. I don't care what side of the political spectrum you're on. That's not right. Inspection, any inspectors here, any electrical inspectors in the audience? Oh good, I can talk freely. If you ever do any of this stuff, get into solar, get out your code book, get used to. We have the toughest inspectors in southeast Minnesota than anywhere I talk to, and I'm talking with people across the country. There are things you can install up in Minneapolis that you cannot install in Preston, Minnesota. For example, the Tesla car charger, can't install that in Rochester. Tygo optimizers, I'll get into what those are here in a minute, but Tygo optimizers, this is the second largest power optimizer company in the world. They have optimizers in 6 continents. You can put them anywhere in Minnesota except for southeast Minnesota because of one little low voltage communication box. Even if you get a letter from Intertech saying they're okay. Still not allowed in southeast Minnesota. Labeling, make sure you get your labeling right. Labeling is a whole nother talk. Yeah, having that picture slightly covering the labeling, that was on purpose. Getting into the equipment selection, these are a few things I'm looking for. I'm going to try and go through this quickly. When I'm selecting equipment, this is what I'm looking for. First of all, you got a 25-year warranty. The manufacturing market in solar is very volatile. So I want a large or diversified company. I want a company that has a bunch of other things, maybe like a Panasonic, for example, although I don't like them for other reasons, I'll tell you why. But they're diversified, right? Even if their solar division tanks, the company's probably not going to go out of business. Or I want a really, really big company. This happens to be Solar World. I like them. They're not the only panels I install. It's the largest American manufacturer. I like the size. I'm looking for vertical integration, meaning they made every step of the process or just about every step. Certainly the cells, if they made the cells themselves, that's the most important part. If a company that makes their own cells gets a bad batch of cells, they walk down the hall and say, guys, fix your coffee maker. If a company gets a bad batch of cells from China, you really got to think about, is it worth sending those back? China makes more solar cells than anybody, of course. All 4 Minnesota companies are, they say they're Minnesota manufacturers. All 4 of them are Minnesota assembled. Okay, it's final assembly done in Minnesota, so they can qualify for this Excel rebate. They're not bad companies, but that's just, most of them get their cells from China, for example. Good value, obviously you want to have something that isn't going to break the bank. Manufacturer location is important to some. You got to be careful though. Canadian solar is made in China. Got to be careful of that. Power tolerance. Now, some of you know this. Solar cells come from solar crystals. Solar crystals are a naturally growing substance. They grow this crystal, they slice them up, and you got cells. Just like if you take a tree and slice it up, no 2 slices are going to be exactly the same, right? Same thing with solar cells. So when it says 250 watts, what does that mean? Well, it's not going to be exactly 250. It's going to be maybe 252.37 watts or something like that, because everyone's going to vary. Now, if they have a positive power tolerance, meaning that it's going to be at least 250 or could be 3% higher, that means they get, okay, we got a 252, put it in the 250 pile. We got a 247, put it in the 245 pile. So it's always a positive power tolerance. There are major manufacturers that have positive negative power tolerance. And these are some brand name ones, like, well, like I said, Panasonic. Samsung has positive negative power tolerance. I think that says something about your quality control when you can't guarantee that my 250 watt rated panel isn't at least 250 watts. Panels are often wired in series, at least for old string inverters. This string is, with the positive power tolerance, is going to do a lot better than this string. DC optimizers and microinverters. I'll go through this quickly. The string inverter is where you have a string of panels. It's just a circuit. I don't know why they call it a string. It's just a circuit of panels to get the voltage up to the inverter input range. And the they're all wired the same. Of course, solar panels are semiconductors. Nature of semiconductors is any part that isn't generating actually turns into a resistor, right? I think you guys know this stuff. You can hook up a solar panel to your voltage tester, put a business card. The full-size solar panels are 18 1/3 square feet for residential size. If I put my business card over it, you'll notice a difference. It's really that much. Well, if you're wiring them all together in series, that can be an issue for the whole string. So what they said is, wait, instead of one big inverter in the basement, let's put a little tiny inverter on the back of each panel. Not a bad way to go, because now each panel is completely optimized. Doesn't matter what your power tolerance is. Each panel is completely optimized all the way throughout the day. You are adding some parts. So they also came up with a hybrid system called DC optimizers. So these two function the same, have some benefits. I'll send this to you if you want to nerd out about it. Cool monitoring systems. You can see this is a microinverter monitoring system here in town, where they've got a tree, you know, over here that shades it for part of the morning. And you can see this is kind of it waking, the panels waking up in the morning. Each one can function independently without dragging the other ones down. DC optimizer, same basic system. Both. There are things called AC panels where the microinverter is, you know, embedded in the panel at the factory, or we install. Issue with microinverters. This is why I recommend against microinverters. Electrolytic capacitors out in the freezing and thawing cycles. Don't put in. Anybody here work for N-phase? Okay, good. Don't put in N-phase. They have electrolytic capacitors out in the freezing and thawing cycles. They're not going to make it for 25 years. If you go microinverters, go the step up, go with EPS. Yes, they're made in China, but they have ribbon capacitors. DC optimizers, the reason I like them, 250% less parts on the roof. You still have all the other benefits, but you're dealing with a lot less parts on the roof, a lot less failure points. I probably got 100 kilowatts of microinverters out there before DC optimizers got big. I've got about 100 kilowatts of microinverters out there. I've replaced 3 so far. I've got at least 200 kilowatts of DC optimizers, probably closer to 250 now. I've replaced 1 and it was bad off the truck. It never fired up. Other parts, I won't get into this. Questions to ask your solar installer. NAPCEP certified experience. I think equipment selection is important. Roofing experience, I don't put up anybody on the roof unless they've got roofing experience. That's just my bias. Not all flashing is created equal. Flashing is the part, let me just show you the picture here. Flashing is the part up here that is waterproofing the shingles. Not all flashing is created equal. Not all sealant is created equal. I'll put this up here. GeoCell roofing sealant, best roofing sealant there is. Don't use the 3300 line though. They say it's an upgrade from the 2300 line, but it's not rated down to 40 below. So here in Minnesota, don't use the 3300. You got to be careful about that stuff. Oh, I guess I will talk about this quickly. Notice a different company for my flashing versus my racking. They both make both products. Snap and Rack is old roofing guys. They've got this awesome flashing system that is great. Their racking is terrible. DPW is structural aluminum guys. Their racking is great, their flashing is terrible. Where is equipment made? Can I add more later? I've already probably gone a little over. First of all, are there questions? Why don't I do that first? Well, we have it till 9. Well, let's not be here till 9. What do I have for questions? For a house system, probably 5-6 kilowatts is average. Business systems, generally, you know, I'm in the 20 to 40 range. I've installed, just for your guys' info, I've installed 1.3 megawatts of solar in southeast Minnesota. 2010, it doesn't seem like is a long time for a business. We're actually one of the oldest solar companies in Minnesota. We're older than probably 80 to 90% of the solar companies in Minnesota. So just to give you an idea of the market, compared to California, we're young pups. Other questions? Yeah. Yeah. So, well, you could see in here, well, here, right here, these blue cells, anytime you saw a picture of blue cells, that's polycrystalline. The black cells that I have up front here, any of the pictures that have black cells, monocrystalline, okay? Monocrystalline costs a little more to manufacture, so the panels cost a little more, but they're more efficient. They do a little better in low light situations, so every day they wake up a little sooner, go to bed a little later, they produce a little more. When we started out, it was all polycrystalline in, you know, first probably 3 years, just because cost-wise the monos were here and the polys were here, and now the monos have really come down to the point where they're cost competitive, so I'm doing a lot of monocrystalline now. They're still both out there. In a situation where you want to come in at the lowest cost on a competitive bid situation, probably going to be polycrystalline. On a house system where you're limited by space, it's probably going to be monocrystalline. Yeah, good question. So efficiency, so we're talking about percent of sunlight that's turned into electricity. Polys is in the teens, mid-teens, I'd say. Monos is in the high teens-ish. Yeah, good question. Average cost, I would say, well, let's see. Residential systems, I can pick this out of the RPU brochure on solar is a good source. They have a real frequently asked questions brochure. System cost residentially upfront would be 10,000 to 40,000 for residential. Average would be in that 20 to 30 range, is kind of my middle 50%. That's the upfront installed cost. There's obviously the tax credit off of that. RPU people, you're lucky because RPU has another rebate that's about 10-15% depending on the complexity of your setup. Excel's got some big rebates. Co-op territories don't have any rebates. Yeah, good question. The question was break even or return on investment. Boy, I've seen as little as 2 years. That was a really odd situation. I've seen as high as 20 years. I would say my middle 50% for residential is about 8 to 12. My business systems pretty consistently around the 6 to 8, depending on complexity, of course. Businesses, of course, have that accelerated depreciation, which really helps out. Also depends on how much electric bills go up. I usually put it at the national average, 3.78%. You know, what's going to happen with the clean power plant, who knows? So if that goes through, electric rates are going up, and if that doesn't go through, we're probably going to stay at that 3.78%. It was interesting, I was in an RPU board meeting. This was in December, I believe. And SIMPA, SMMPA, is the power supplier to RPU. RPU generates very little power. They get their power from the Southern Minnesota Municipal Power Agency. And SIMPA's pricing is going up at 6% a year. And that's where RPU gets more than 2/3 of their power. So that was really interesting to see. I was surprised by that. And that was before, this is before the clean power plant. And there's a reason we use coal, it's cheap. As long as you don't count the asthma. I have asthma, so that's a big thing for me. If you want to search something scary, notice I'm not even going to talk about global warming. I'm not even going to talk about that. That's not what this is about. If you want to search something scary, PM 2.5. For those of you in the medical field, just search PM 2.5. Correct. Average retail rate. So in the net metering setup, if you're producing more than what you use in an average month, if you're producing the same, they just kind of zero it out. If you produce more than what you use in a month, you get paid for it, what they call average retail rate. Why average? Well, power costs are a little bit different summer and winter. I don't know if you've ever seen that on your bill. About a penny different, penny and a half in Tri-County area, difference between summer and winter rates, so they just average it out. So I do have some people that produce, you know, let me back up. Most of the time, I size systems to cover what you're using. Most of the time. I do have a few people that say, well, hey, I can be selling power and making money on this. And I say, well, yeah, you can, but that's income. You got to pay income taxes on that. Suddenly that 11 cents that they're paying you for the power is down at, you know, minus 25% for income taxes or something. There's a different, it's a different cost structure then. So I just caution people against that. Most of the time I size it for what you're using. Yeah, each one is a little different, so it's hard to generalize, but co-ops are charging an extra fee for the solar, to interconnect to solar. People's co-ops deal with SECA. And it's based on how much you're putting in. If you're putting in just, you know, 5 kilowatts, it's different than if you're putting in 30 kilowatts. Usually they're topping out somewhere in the $30 to $50 range. Every co-op's a little different. I wish I could generalize more. People's co-op is $2 per kilowatt, exempting the first 3.5. So if you put in a 4.5 kilowatt system, that's 1 kilowatt over the 3.5 threshold, so you get $2 extra. Max being about 35, 37. No. Correct. You can get to zero on your bill if you're producing more. Well, what RPU is going to do, because they provide the water as well. First thing they're going to do, if you're producing more than what you're using, they're going to zero out your energy charge, which is I think $16.40 a month was the meter charge with RPU, and then they'll start crediting your water bill. That's what they'll start crediting. Again, I usually caution people against using this as a moneymaker, you know, as far as getting income, just because you're paying taxes on that. Other questions? All right.
I appreciate you coming down. Thanks very much. And as a gift, we got a nice coffee mug for you. Fantastic. Again, I guess I can introduce myself quickly. I meant to do this at the beginning of the meeting, but I kind of got pulled up in the back with some of the problems we have with our online presentation. But I am the new section chair, Dave Paulson. I appreciate the 6 or 7 of you that voted. I think it was unanimous even. So you know, that's an accomplishment too. So I'll be here all year. I'm still actually going to maintain my position as well with the student activity chair, which is with the student branch out of Mankato. So as you'll see me around. If you have any questions, feel free to interrupt me and stop me what I'm doing and give me your